Hi, welcome back. So this time we're gonna tackle the last two cases of the integration of rational fractions. We're in for case 3, the denominator is composed of quadratic factors, and we will also tackle the case 4 wherein the quadratic factors is repeated. Okay, so for case 3 we have the rule like the case 1 and case 2, but for this case we have for the quadratic factor. So we say we have this quadratic factor here in terms of ax squared plus bx plus c, right? So last time we tackled the linear in forms of this one, but this time we have the quadratic factor in terms of ax squared plus bx plus c, where our b squared minus 4ac is less than 0. Okay, so this associates the sum of partial fractions as follows. So this is our formula. If we have some n of x, or some function of x for our numerator all over the quadratic factor at the denominator, then it is the equivalent partial fraction is in terms of a, which is the constant, multiplied by 2ax, where a is a constant in our quadratic factor, plus b, the constant in b of x, and then plus another constant b to be determined. So for our case 3 we need to determine the values for constants a and b, and this will the denominator will be this one, the ax squared plus bx plus c. Okay, so for the case 4, the denominator is in terms of repeated, okay, or the quadratic factors is in terms of repeated by because it is raised to some number, or we say that it is raised to n. And like what we've done in case 2, for repeated quadratic factor, it is now equal to a1 times 2ax plus b plus b1. Oh, this is another constant all over the ax squared plus bx plus c raised to 1. So for the first, until such time that we will add similar formula until such time that we will we're gonna have our denominator equal to n. Okay, so we will end our formula until such time that our last value here is also equal to our power n. Okay, so for illustration, let's have illustration on how to apply this rule. Say let me rewrite our form. Say we have some function of x. Say we have 2x all over 4x squared plus 2x plus 16. Say we have something like this. Okay, so since this is our quadratic factor, this one is our quadratic factor in form of ax squared plus bx plus c, wherein our a here is 4, our b here is 2, then our c here is 16. But since it is only raised to 1, so we will adopt the rule for case 2, wherein it is equal to a 2ax plus b all over ax squared plus bx plus c. Okay, so following this formula, we have, instead of this term, we can write this in this way. So we have a, the constant to be determined, multiplied by 2, and our a here is 4. Then we have x plus our b is 2, and plus another constant to be determined all over our quadratic form, which is 4x squared plus 2x plus 16. Okay, so another illustration. Say we have, let me erase this first. Say we have x minus 1 all over x squared minus 2x plus 3, this being cube raised to 3. Okay, so since it is raised to some number n, we will adopt our case 4, wherein we have the quadratic form inside, but it is repeated up to third degree. Okay, so we will adopt our case 4 because we have this quadratic form but is repeated to some n raised to some n. So we will adopt this formula. Okay, so by doing that, we have, say, this equal to a, then 2, our a here is 1x plus our b is negative 2 plus b all over 4, x squared minus 2x plus 3. So this is our first term raised to 1. Then we need to add some more. Add some, let's have another letter, say c, multiplied by 2, 1x plus negative 2 plus d all over x squared minus 2x plus 3, but it is now raised to 2. Okay, until such time that our n became 3, right? Because our n here is 3, so we will end here. Then for let's use another letter, say e times 2 times the ax, which is 1x, plus b, which is b is equal to negative 2, plus f. Okay, so you see, based from the formula of our case 3, we've followed the a 2, then our a x plus b plus b all over the ax squared plus bx plus c, right? So for our case 1, we've followed this formula. Okay, so once again, let's review. So this is our example, and based from our rule, it is equal to some constant a to be determined multiplied by 2, and a, which is the value of our a here, is 4. That's why we have 4, and then our x plus the value of our b, wherein the value of our b here is 2. Then plus another constant to be determined, so we assign it as letter b. And then all over this whole quadratic form. Okay, we have 4x squared plus 2x plus 16. Then for our second example, which is under the case 4, since it is now repeated up to third degree, so our formula here is that a1 2 times ax plus b, then plus the another constant to be determined, then x squared ax squared plus 2x plus bx plus c. Okay, then plus na a2 2ax plus b plus b2 all over a x squared plus bx plus c, but it is now raised to 2, till such time that our repetition is equal to n. Okay, so applying this rule 4 is from our example. We have the quadratic form, terms like this, but as you can see here, our we designate our first unknown constant as letter a, so this is our letter a, then multiply by 2, and then the value of our a from our quadratic form is that 1. Okay, right, we have 1, so we write 1, then x plus our b is negative 2, so we have b, and then plus another constant, wherein we designate it as letter b all over the quadratic form, but raised to 1 muna. Then we need to add some more, so we have designate this a2 as letter c, then 2 again, and our a is 1, then x plus again negative 2, rb is negative 2, then plus another letter all over the quadratic, but now in raised to 2. Okay, so until such time that our n is equal to 3. Okay, so if this is equal to 10, so we need to add similar forms up to 10. Okay, so all over the quadratic form raised to 4, then all over the quadratic form raised to 5, until we reach the quadratic form that is raised to 10. Okay, so in our next video we will gonna have some examples regarding this rule.